So welcome to our monthly CEU webinar exclusively for ILFI's member community. I will turn it over to our speakers for today after a few short announcements from me. While we're getting started, please go ahead and introduce yourselves in the Zoom chat. We love to see where folks are calling in from and some professional details as well. I will kick us off in the chat. I'm Liz Harder. I am ILFI's Member Engagement Director, and I'm calling in today from the Twin Cities in Minnesota. And just a note that we encourage everyone to use the Zoom chat a lot today. We'll be using it for the panelist Q&A, so feel free to just use that space freely to connect and ask questions. Now, to quickly cover CEU information, we're going to be hearing from two ILFI member communities who have deep insights into embodied carbon solutions in the exterior built environment and landscape architecture. Our learning objectives for you all is that you walk away with more information about the positive impact our exterior built environments can have, as well as the strategies and tools that you can use for reducing emissions and increasing sequestration. Everyone in attendance live today is eligible to receive one LFA general credit and one AIA LUHSW. If you don't know about LFA yet, feel free to scan the QR code that you see on the screen here, and you can explore more information after the webinar. And we'll also be including more information about your CEUs, along with a link to the webinar recording and a follow-up email after we wrap up today. So a few quick announcements for our members. We have some upcoming member events, including a CEU webinar series the week of November 6th. These webinars will be covering the 7 petals or performance areas of the Living Building Challenge. And we've also got some fun meetings and workshops being held by our regional member communities, which I'll talk a little bit more about in a second. And if you're new to the community, be sure to join our next member welcome call on November 30th. These calls are a great way to learn more about your benefits and get a chance to meet other members as you're joining. And for those of you looking to connect with like-minded members in your area, be sure to check out our 7 active regional member communities. These groups are designed to help our members gather and collaborate and organize for the regenerative buildings movement in their local region. So they're currently planning educational sessions, in-person living building tours, and a lot of really other exciting connection opportunities. So if you're in any of these areas or close by, be sure to head to the member dashboard to join your group and meet those members in your region. And then lastly, our team is looking for information from our community about what education you need. So it's a short 2-question poll. It's going to be available in the member dashboard and also will be included in our next member newsletter on November 8th. So share your thoughts and so that we can produce some really good education for you. So with that, I'm going to pass it over to my colleague, Jessica, who will share a bit more about our speakers and the agenda for today.
Great. Hi, everyone. Thanks so much for joining. I'll do a quick introduction here and some perspective on this context from ILFI, and then hand it over to our esteemed guests. So today we have joining us Pamela Conrad. She's part of ASLA, is a lead AP, is a faculty lecturer at Harvard's Graduate School of Design, and is an Architecture 2030 Senior Fellow. She's also the founder and executive director of Climate Positive Design, and I'll let them get into a bit more of what they're doing with that work there, but really impressive background. And same with Chris Hardy, ASLA, certified arborist, and is a senior associate and landscape architect at Sasaki, and is doing a lot of his work alongside Pamela, and we're really looking forward to their presentation. My name is Jessica Bristow. I'm with our Programs and Innovation Group here at ILFI, and I'm the director of our Living Building Challenge groups, which encompasses all of our building certifications. So Living Building Challenge, Zero Energy Certification, and Zero Carbon Certification. And we're really excited to get into the conversation. So yeah, we can jump to the next slide there. Liz, please. So today we'll have this quick introduction, and then we'll hand it off to Pamela and Chris for the presentation from Climate Positive Design and Sasaki. They'll go through some of the impact of the exterior built environment, the Sasaki Carbon Conscious Tool for Early Design, Climate Positive Design's work, and the Pathfinder app. and also some of the coalition work and alignment that they're doing all together. And we'll have some time at the end for Q&A and resources. And as was mentioned, please use the chat throughout, and we'll be collecting those questions and helping with the Q&A as we get towards the end there. And so I want to take a brief moment to discuss what's the role and context here with ILFI. So what does this mean at ILFI? What role can our sites, landscapes, and infrastructure projects play in reducing emissions from operational and embodied carbon while increasing sequestration? And can projects sequester more carbon than they emit? So these are things we'll be learning about in this presentation. With the recent and rapid increase of data and newly available tools, we look forward to learning more and understanding our design considerations beyond the building and into the environment, and reaching for the aspirational goal of climate positivity. So LBC does address buildings, landscapes, and infrastructure projects at all scales, and is an inclusive tool for transformative design. Whether the project is a single building, a renovation, or a park, LBC and our core frameworks provide guidance on design, construction, and improvement of this relationship between people and aspects of the built and natural environment. And we have a lot of teams, some of you on this call maybe, who are asking you to go further and wanting to consider their sites and landscapes in a more deep and holistic way, not just for our place pedal considerations or resiliency or community improvements, but also to understand the carbon impacts and accounting in that area too. So with our carbon requirements across LBC, core, and zero carbon, we're excited to see where it can go. And with that, I'm going to hand it over to climate positive design and Sasaki. So Chris, you can take it away.
And Jessica, I think you did a great job of summarizing our why for being here. But just to quickly reiterate, we believe that beyond buildings are often looked. That makes up half of our cities. And we want to spend time talking today, having a conversation about how those spaces can not only provide mitigation benefits to the climate crisis, but also provide a myriad of other benefits when we're designing holistically. So we're thinking about resilience, we're thinking about biodiversity, community health and well-being. And so that is what we are going to unpack today. And just because recognizing many of you may be coming from the building side, we wanted to start the conversation with that framing to understand really, get some level setting of general global emissions. So this is from the latest International Energy Agency data, Architecture 2030, and Climate Positive Design have been working to pull out those pieces. It's quite complicated to understand. So this just shows you what probably many of you are familiar with, that around 27% of global greenhouse gas emissions are coming from building operations. The good news is that with renewable energy, that is already starting to go down on an annual basis, which is fantastic. And then when we start to look at embodied carbon emissions from those emissions from the extraction, transportation, manufacturing of the materials that go into the places that we build, that adds another 15%. So now we're up to about 42% of the built environment emissions as part of the overall pie. Now, looking at infrastructure, that's actually pretty significant. Just 3 materials alone when looking at buildings and infrastructure, cement, iron and steel and aluminum are really significant. That makes up the majority of embodied carbon emissions. And so that 7.3% is significant considering it's only 3 materials in infrastructure, and about 75% of the infrastructure for 2050 is yet to be built. So this represents a significant opportunity for us to improve those emissions going forward. And then lastly, also trying to understand a little bit better when we start to think about the entire exterior built environment's impacts, when we start to think about planning that goes into transportation from our roadways and also our sites and landscapes, that starts to paint the picture of how the UN Habitat has made the estimation that 75% of global greenhouse gases are coming from the urban built environment. So we have a significant opportunity to play in this overall challenge, and better understanding it is going to help us get there. So I mentioned those 3 significant materials that include most of the embodied carbon emissions globally. If we look at the left, that breaks out cement. And so from buildings and infrastructure alone is basically the entire cement manufacturing production in the entire world, right? And so if you If you separate buildings from infrastructure, it's about 50-50. So again, pretty significant emissions just tackling cement and concrete in the exterior built environment. Then moving iron and aluminum, again, it's about a quarter of that is going to infrastructure compared to buildings. So again, significant opportunity areas that we can understand and improve upon. But that being said, that kind of got us down into the weeds quickly, but we want to step back up and talk about kind of this overall emissions impact hierarchy. We know that the sooner we start thinking about this, the more significant impacts we can have on our overall positive contributions of our project. So first, starting with nature-based solutions and building for resilience, protecting and restoring our natural ecosystems, smart growth, smart planning, making sure that we are reusing and renovating existing buildings and materials, and then really getting into the designing of the efficiency of building systems and then implementing clean construction sites. And Chris is going to talk a lot about this. But again, just to put it into context, recognizing how much infrastructure is going to be built in the coming decades, and we know that about 75 to 90% of those emissions are embodied, and where they're coming from exactly, that's the real opportunity for us to also start looking at the alternatives, right? Shifting from gray infrastructure to green infrastructure are many opportunities, not only less emissions, but also those co-benefits that I mentioned, and they're significantly underfunded, even though they typically, according to this Yale study, cost around up to 70% less of traditional engineering and infrastructure. So that can be a win-win if we can get more of those projects implemented with a green infrastructure approach. And not only that, we can also contribute to that ecosystem sequestration, which is the potential for 30% needed by 2030. So I'm probably preaching to the choir here, but we see all of these opportunities here that we want to unpack today and help us understand how we can implement them, again, to support equity, to support the biodiversity crisis, to reduce global temperatures, and also preserve our natural resources like water. So Chris is going to go ahead and jump in from here.
And let's see. Hi all. So I'm Chris Hardy. I'm a senior associate landscape architect at Sasaki and the primary researcher for our carbon conscience effort. And the reality that we're facing is that every act of construction, every material has global warming impacts. And I think quite often our profession as landscape architects tends to think we're on the side of the angels, but we need to reconcile with the embodied emissions side, that 75% and 90 to 90% side of the net overall impacts of our work in the built environment. Now, I think we're used to thinking about the carbon cycle in construction as a linear process. The architectural and engineering communities have been grappling with this in detail for almost 20 years now. The first focus was on the operational side, energy efficiency buildings targeting net zero operational carbon. Now there's been a focus in the last 10 years on embodied carbon. To clarify, when I say embodied carbon versus operational, as I use those terms a lot later in this talk, for embodied, I'm referring from material extraction and creation through the construction to the facility and at the certificate of occupancy when people start using the facility, whether it's a park or a building, that's operational carbon. Now, this linear approach to carbon cycles in construction is kind of in direct opposition to what we think about in the biological and life sciences carbon cycle, which is a circular cycle in the living carbon. That's photosynthesis, pulling carbon out of the air into living and dead biomass, some of which ends up getting stored long-term in ecosystems, the decomposition of biomass, and the respiration of living things, releasing carbon dioxide back into the atmosphere. Now, natural resource sciences have been investing in this research to better understand our living carbon cycle over the last 20 years as well. When we talk about carbon sequestration, we're referring specifically to carbon that's being pulled out of the atmosphere versus the carbon stored, and that's carbon that's locked up in the tissue or in the soils of the living ecosystem. Now, when we're working with living systems, there's a unique opportunity in the built environment. For only in living systems do we have economically viable ways to draw carbon down out of the atmosphere. All other carbon drawdown technology is speculative at this point. Plants are very good at this. They've been doing it for a very long time. They're self-regulating, self-healing, self-replicating. All we need to give them is the appropriate systems to thrive. They're a perfect technology. When we started thinking about carbon analysis at Sasaki, we began by using existing tools, including the beta version of Pathfinder at the time on some of our landscape projects and using Tally and architecture. And we immediately found unintended consequences. We realized that we were having unforeseen carbon impacts in our projects that we had no idea of. We realized that we didn't have very good basic understanding of carbon and the trade-offs that we were including in our designs at the time. But because those tools generally required more accurate bills of quantities of materials, it was a little late in the process for us to change course. And we wanted to ask, how can we start to consider carbon at the earliest design phases? Perhaps before there's a project, how do we prepare clients for the potential understanding of what these impacts can be? We wish we could go back to the beginning, maybe when we were doing our earliest sketches and reassess and where we were going. Our team realized that there's power in planning. And as a firm that does a lot of urban design and planning, we wanted to kind of go back to those early planning and concept design phases when there's power to fundamentally challenge and guide the framework of what the project is. If we can harness the power of planning for carbon goal setting, then we can set up the technical phases for greater success. Now, this is not to say that it's not important to continue to assess carbon impacts and carbon storage potential in projects throughout the technical design phases, because the way our construction industry works right now is that there's a gravity to business as usual that's going to pull projects back towards typical practices right now, unless there's a consistent check-in and ultimately the enforcement of the low carbon design in construction administration. Now, as a practice that combines architectural, landscape, and civil engineering disciplines, we also recognize that the contemporary whole building life cycle assessment standards out there typically omits site infrastructure. It's considered an externality. This missing externality can be a big omission when we're talking about all of the carbon that's included in the site infrastructure to hook up associated facilities. But it's also a missed opportunity in thinking about the living carbon, the carbon sequestration potential of restored ecosystems, or storage potential of living in ecosystems. You can imagine that for this given project, the LCA, the whole project lifecycle assessment, would look very different if we're just looking tightly around the building versus the restored ecosystem preserve that we were including in the overall site design adjacent to it. So we need to rethink our spatial boundaries of our LCA efforts to start to include the site. Ultimately, what we wanted at Sasaki was a planning phase tool to help generate high-level whole project LCAs, inclusive of landscape, infrastructure, and architecture, to guide our work. We decided to use land use as the common unit of measurement, as land use is the single most common unit of decision-making at the planning scale around the world. We chose to focus on just the embodied carbon sequestration and storage. Part of the reason is that we need to consider embodied carbon uncoupled from operational, especially for site work. Another reason is that we emitted operational carbon is that there are high quality, good tools already for considering energy model in operations and planning phases, such as the Cove tool. And for landscape, quite often, you can make the decisions of your operational approach to carbon and your embodied approach to carbon as two independent decisions that need to be made throughout the design process. To build a database of land uses, we first combined a list of common typologies of built landscapes, developed assembly coverage assumptions, and then mapped carbon factors to those materials and products, ultimately generating over 260 unique landscape land uses. In our current version that's posted now, version 2, we built our architectural database from the Carbon Leadership Forum survey of whole building LCAs from 2017, and then included modifiers for structural and facade systems. We included multipliers for floors above and below ground, This data set, though, is being replaced by a version 3 later this fall, hopefully before January, where we are collaborating with EPIC by EHDD. To put this research into the terminology of whole life cycle standards, our data set only accounted for stage A1 through A5, so the embodied carbon going into building the facility, replacement costs for land use materials over the life cycle defined as 60 years, matching whole building LCA standards, and then the carbon sequestration potential of the living systems. All of these methods are detailed at length in our white paper. Please check it out. It's a living document, so if anybody has feedback or critique, please reach out. We're actively editing it for version 3. And we've also distilled this research into a land use mapping application, Carbon Conscience, where you can create and save your master plans, defining land uses by typology and material, inclusive of architectural, civil, and landscape land use elements. Draw them in the tool or upload images in a kind of a paint by number format. You get quantities through these drawings. It does raster image analysis. We've also enabled land use splitting and layering so you can better evaluate ratios, such as a landscape plaza. You don't know what the design will be, but maybe you start by assuming 80% is cast in place concrete, 20% is stone veneer, and then you can continue to edit those ratios over time, or maybe your baseline material assumptions. Or you perhaps can adjust a ratio between mass timber structure versus steel for a building typology. With over 400 land uses total, this splitting enables countless possibilities. With our new layering function that'll come out in version 3, you'll be able to add demolition layers to finish uses or add things like green roofs onto buildings. In our beta testing, we learned that many users wanted to use the tool to advocate for material design guidelines, to also help guide, especially on the planning side, for future consultants they may be hiring for their projects. So for those deep dive users, we've enabled the material assumption editing, where users can adjust assumptions such as supplemental cementitious material requirements or percent recycled content standards or local sourcing transportation requirements. The results show the balance of embodied versus sequestered and stored carbon. These tables can be exported to a variety of formats for designers to use. We also provide estimates of areas of key ecosystems that would need to be restored to offset a project's carbon footprint. We've made this tool open source and freely available to the design community. But I do want to be clear, this is not an ISO 14044 or 40 LCA standard reporting tool. This provides just an apples to apples comparison between common land uses in terms of the carbon impacts. This is for planning and concept design phases as a complement to the specific quantity analysis tools that are useful and necessary for reporting standards and technical design phases, such as Pathfinder and Tally. We've been using this tool and evolving and advancing it in practice, and we have learned that informed goal setting in the beginning of the design process ultimately can be used to inform land use and program decisions that helps drive material and detail standards and expectations, making low carbon design part of our fundamental expectation for success in design. This enables designers to be better advocates for decarbonization and restoration ecology, and helps us take responsibility for the impacts of our work. So with that, I'm going to hand it off to Pamela.
Awesome, as always, Chris. Thank you. Hi again, everyone. So just to briefly mention that our mission of climate positive design is to have a positive impact on the climate and biodiversity crises in the exterior built and natural environment. We hope to accomplish that through advocacy, education, and design. And my context to coming from this work is that I've been practicing landscape architecture for the past 20 years or so. And the last 10 was really focusing on coastal adaptation, sea level rise adaptation projects, primarily in the Bay Area. And what I found is that while we were having lots of conversations around, how we were going to adapt our cities and urban environments, as a designer working on these projects, and this was, 7 or 8 years ago, at this point in time, we weren't talking much about what our contributions were to the causes of climate change. And, I think we've generally understood some of these concepts, like creating cities that are more walkable and bikeable, reusing materials, using low carbon materials, plants that sequester more carbon, and restoring and protecting our natural ecosystems. But it really was a question that I had about 5 years ago then, I wanted to measure the carbon footprint of my projects, and that tool just didn't exist yet. There was information for buildings, there wasn't anything that was putting together both embodied carbon emissions, operational emissions, and also carbon sequestered. And so mostly kind of out of frustration that it didn't exist, I started pulling together the data sources and creating this tool myself. And what I found was pretty shocking, actually. It was projects that I thought that were really sustainably designed. We're coming up with, this is showing the metric tons of CO2 emitted on this couple acre park project and sequestered, and then it's showing me that it would take about 15 years to offset this project carbon footprint, which I thought, well, that seems like a lot. This is really sustainable green park place. And what I found, though, is when I had the information in front of me, that I realized I could have made some simple changes that could have significantly improved its carbon footprint, using materials more specifically, lower carbon materials like stabilized crushed stone paving versus asphalt, adding some trees, converting some of the lawn areas into shrubs, specifying electric maintenance equipment, and regrading to reduce some underground infrastructure. So that project, instead of taking 15 years to offset its carbon footprint, could have been accomplished in 5 and still maintain the same quality, aesthetics, and performance. And the project's case studies actually got much more shocking. This was a half-acre plaza project that would take almost 200 years to offset its carbon footprint, which was frankly pretty embarrassing. But then again, that pattern continued to emerge, that we could have, again, used cement substitutions in our site concrete, added some trees, use more planting, use less concrete, use more wood, and instead of it taking 200 years to offset its carbon footprint, that could have been accomplished in 20. And at the end of the day, again, still performs the same way, is just a little bit greener. And so it was with this insight that I realized that we basically, as a business as usual for our profession, was showing us that we're likely emitting more carbon than we're sequestering on our projects, the graph on the left. And when we start to make these simple changes, that not only could we reverse that curve, we could have a significant positive contribution to drawing down carbon if we then make just those simple changes that I was showing you in those case studies. So, reversing it from being net emitters to being, on the graph on the right, net positive, and potentially taking a significant amount of CO2 out of the atmosphere beyond offsetting our emissions by 2040. And so with that, I launched the Climate Positive Design Challenge. It sets targets for how many years, ideally, projects would offset themselves. And so 5 years is set for kind of greener projects that more like parks, campuses, hospitality, and then 20 years for more urban spaces like plazas and streetscapes that inherently have more paving to accommodate their programming. And again, so with this overall goal of collectively scaling up our positive impacts together, and a more maybe ambitious goal than just being zero or neutral is this idea of being climate positive. And also just want to recognize too, though, we do know we can be reaching these or striving to reach these goals now, which are basically it's sort of getting the sweet spot, right? You both have to both reduce your emissions and increase sequestration to hit the target. So it's generally around a 50% emissions reduction and doubling sequestration, sort of from business as usual. We can continue to do that till, basically 2030, but then we really need to start ratcheting our emissions down. We know we need to actually get to zero emissions by 2040. Obviously, ideally, we're trying to not have the worst impacts of climate change happen. And so, this is a gradual reduction, but just pointing out that we do need to be kind of evolving our targets over time. And to meet the goals of the challenge, you can log your projects in the free web-based app called the Pathfinder that I developed. The primary original data sources were coming from Athena and the US Forest Service. And it was designed with the idea in mind that this should be easy. You should be able to get feedback to understand what you're doing, and it should also be able to pretty seamlessly work into your existing workflow. And so you basically provide quantities. I'm going to do a little quick demo, and then you get instant carbon feedback. So you get a red number for emissions, green number for sequestration, and then a live years to positive score. So hopefully this will play. So you go to the website, climatepositivedesign.com, go to calculate, and you hit use Pathfinder. And there's a little demo just when you get started to show the factors of carbon sequestration and carbon emitted. And the relationship between the two is that obviously the more that you emit, the longer it takes you to offset that. The more that you sequester, the less time it takes. But ultimately you have to do both to, as I mentioned, to meet the goals of the challenge targets. So when you get into the app, you can type in your address or your general location, and you can basically, it's going to take you to your site. We're going to Los Angeles today to a green roof. And so once you can zoom in here, and even if this is tedious, hopefully it just makes it easier for you when you go in and do this on your own. So you zoom into your site, and then you're going to select the polygon tool to just outline the boundaries of your site. It can be crude, doesn't need to be perfect. You just click on the points at the boundaries, and then use the check mark box to move forward. It gives you the rough area, which you can refine. You just need an email address to set up an account for a project. It's free again. And then when you get in there, you can give it basic parameters: title, description, what kind of project it is, estimated completion date, because it's actually going to tell you the year that your project becomes climate positive, your units, if you're pursuing any other certifications, and you should get ILFI in here as well. And then if it's a study project not expected to be built, you could go ahead and check that box there at the bottom. It will exclude it from our professional data contributions. Once you get in, you can do a design alternative or existing condition, and just give it the basic naming. Again, all this stuff you can edit later once you get your project going. And you'll see that there's a little demo to see. You can either search or use the drop-down category to get started. And you can get going by adding basically some quantities for your materials for your project. And so you can see here, when you click on the materials tab and go under paving, you'll see, 80 to 100 materials in here. And once you find one that you're looking for, again, you can also search those. You select it, it pops over on the right, and you give it some basic parameters, area and depth. And then the red number pops up. That's your embodied carbon emissions. And so if there's something not in here, you can make a custom material by using an environmental product declaration, and you can pop that global warming potential number in there, and then it will also add in directly. So again, kind of the name of the game is just to start building it, again, starting early as possible, because you can get a rough estimate and you can just refine it at any point in time throughout the project. And I do recommend that it's done at least at every project phase, every milestone, so you're keeping up with it. And also helping keep your team on track. It's a good way to keep the conversation going with your clients. How well are we doing? How did those changes affect our overall project impact? And you can see it gets down to pretty detailed stuff in here. You can see gravel mulch is being added. So pretty fine-grained if you need it. Then if you go to the plants tab, you can see there's a range of trees, plants, shrubs, grasses. Once you click on trees, you'll see what happens is you want to select your growth zone, and then enter your quantity for those trees. And you can see that green number that shows up is your sequestration over 50 years, and then it's showing your years to positive score on the lower right-hand corner. So you can continue to add shrubs by just entering in the area, square footage, and then those will also pop up in your overall score. So as you can see now, we're at 20 years to positive, so we're getting pretty close. And then if we go to the operations tab, it shows things like, what kind of equipment are you using? Are you impacting soil? Are you impacting trees? Are gas powered or electric equipment? Those kinds of things that you want to take into account if you can. And at the bottom, you can click the design suggestions. So it's going to give you specific recommendations to what you entered in for your project, lower carbon alternatives for you to consider. And then also, if you go to the version stats and click view scorecard, this gives you a scorecard that you can download that summarizes all the information we just entered and helps you to understand where your biggest impacts are and what to improve upon. And so from there, you can hit the back button and all your projects information gets stored here, which you can edit at any time, duplicate, edit, and then hit the back button again. And this is your project's homepage. So you can have one account with multiple projects in it that you can come back and share within your office or your group that you're working on, and continue to work away. So that's Pathfinder, and I think we're going to have to go pretty quick. through the rest of this, so apologize for that. But why are we doing this? Why is it important to measure? Because it creates a feedback loop that allows us to evolve and informs how we design, practice, advocate, educate, and communicate going forward, so we can shift from just having an individual impact to a larger collective impact. And since launching the challenge a few years ago, this is the first 3 years impact, so it's great to see some solid uptake. We have over 5,000 projects logged within the first 3 years. We've reached over 90% of the countries in the world that have utilized these resources, so it is global, trying to reach as many people as possible. But we are collecting those professional kind of official projects that are also logged to see how they add up, which are estimated planting 1.7 million trees and taking 2.3 metric tons of carbon out of the atmosphere beyond offsetting their emissions by 2040. So you can start to see that how that adds up. That's the equivalent of taking like 500,000 cars off the road. So it's significant when we work together on this. We're able to pull key findings out from the project data. It helps us to confirm that stat that at least 75% of our emissions are coming from our materials, embodied carbon. So it helps us now that we actually have data to confirm this and we know what to target. And just to talk for a bit about specifications and how we can actually start to draw down those key emitters. So thinking about low carbon concrete, we've worked with Architecture 2030 to update the carbon smart materials palette that you can check out on their website. And we know that we can use more local options, use flexible performative specs for our concrete and considered recycled aggregates. We know that clinker and cement is the highest emitting part of the concrete production process. And so looking at adjusting also that clinker to binder ratio, which is really targeting clinker in general, using supplementary cementitious materials. So things like slag, fly ash, silica fume, and working with your contractor to get the right mix. And that's kind of key right there. There's also alternative binders available. And then lastly, we want to make sure that the remaining emissions that we're specifying renewable energy kilns to abate those heat-related emissions. And then also for steel, we can look to and are suggesting highlighting primary versus secondary. So generally, the idea of specifying recycled melting scrap steel versus specifying the type of furnace that is utilized in the production process. There's lots of different furnaces, it turns out. So it's actually a way to really be able to get what you want out, which is lower carbon product. And then, of course, seeking salvage or reclaimed steel. So just an example quickly about where we've seen this when the rubber hits the road working on a project. This is the 22-mile Atlanta Beltline project, and where we were looking at specifically how could we improve the performance on the project. And we were able to reduce the overall emissions by 22% on this project. The largest impacts were looking at our concrete and steel because 69% of the total project emissions were from concrete, 8% was from steel. And so we were able to target those things specifically, and through creative grading and minimizing our quantities, we were able to significantly reduce those emissions. I think one key takeaway here was we were able to get cement substitutions in our pedestrian concrete, which set the standard for Atlanta Transit Authority projects going forward, which is huge. They weren't accepted in vehicular or structural concrete yet, but if they would have been accepted, that project would offset itself almost 10 years sooner. So we recognize that what an opportunity is, one, to start with flat work to try to get these cement substitutions in, but also we need to be pushing for them in structural as well. And then also just recognizing the importance of infrastructure. It would have basically doubled the emissions on this project if we would have included the calculations for the bridges on site. So just another key area to target. And we're also able to increase sequestration by 84%, working on a restoration forest strategy, and also minimizing the trees that were cut down and also laying those that had to be, and reusing them in timber as well. And then also, again, looking at how we can use less. I think just in general, collaboration is key, making sure that we are optimizing our designs and then looking for those low carbon alternatives. Same goes with steel, just making sure that we're designing everything is to be as efficient as possible. Designing for adaptability and deconstruction is pretty huge. And then again, that's just making sure that we're working with our producers and fabricators, because sometimes they have even better ideas than we do as designers. Lastly, just another example, again, a shoreline sea level rise adaptation project and office space development. We were able to reduce the emissions by about 45% on the project from just steel and concrete alone. Again, that was looking at more natural shoreline edge conditions, so not having big concrete and steel along the shore. We laid the shoreline back and used earth to protect it up and raise for sea level rise, and also just being really creative about the materials and the overall grading from the site. So there are resources out there today, as I mentioned, the Carbon Smart Materials palette for you all to utilize. We also just recently released a new Climate Positive Design Toolkit, and we're continuously updating the Pathfinder app as well. And so we can drop a link to those in the chat. And Chris is going to wrap it up real quick, and then we'll have some conversation.
Yeah, so just as a heads up for where all this is growing, a lot of this is happening through collaborative and kind of open source approach to improving the performance of our designs and decarbonizing the design process. We're entering into data sharing agreements between Climate Positive Design, Carbon Conscience, and EPIC, and we're also investigating institutionalizing baseline data sets with third-party groups, including U.S. Forest Service for thinking about carbon sequestration, and possibly Carbon Leadership Forum. The goal of this is if we can institutionalize baseline data sets, and if we can standardize through the Project ECHO the idea of reporting and how reporting would happen with regulatory and certification regimes, then that can enable a lot more innovation in this space, because we think we need a lot more tools, we need a lot more people working on this to help transform our industry. We're also defining a kind of a best practices common workflow, where right now at the planning and concept stage, you can start in Carbon Conscience with the idea that you could then export your design into Climate Positive Design, into Pathfinder as you go into technical phases, and likewise similar collaboration from architecture to CARE tool and EPIC tool for architecture, and then ultimately ending up in Tally when you have a detailed Revit model. Something that's kind of, and the cutting edge of this is figuring out as an industry how we deal with procurement reporting standards, and there's a lot of active conversation happening on that right now of the contractor side. So a lot of this is all coming together. Pamela's been leading the group from ASLA representing the ECHO project. The goal of this is to figure out how we can all be reporting things in the same way, that we know that we're comparing apples to apples authentically across industries, including many collaborators from Architecture 2030 through ASCE, CLF, ASLA, firms and NGOs and nonprofits all in this space, so that we're aligned in how we report on this, which will give us the leverage to be able to help move the industry that creates the products. Again, this is all happening in a collaborative method, so that we can effectively create greater change in any of our individual disciplines or firms can do on our own, because ultimately what we need to do is radically transform the entire construction industry and regulatory industry around how we build, if we're going to ultimately get to a climate positive design as a kind of standard expectation of practice and performance in the future. Pamela, would you like to go from here?
And this just to say, beyond collaboration in North America, we're also going global with this message too. So we've had a presence at the past two COP conferences for the UN, and we'll be there this year. We're speaking in interdisciplinary panels and groups, so we can elevate our message together and collectively. And I think these are global issues that we're dealing with, and so this is important for us to think globally and act locally. And then I think we just have one more slide, and I also just wanted to end on the note that it's just not about, this isn't just about carbon accounting. At the end of the day, our goal here really is to support those that are going to be the most impacted by the climate crisis and stave off those most devastating effects. So I believe when we approach things holistically like this, we have a real positive opportunity here. So thank you all for joining us and listening, and also the call to action too. There's lots of space to get involved, as Chris mentioned. So come on board. We're a nice group.
Great. Thank you so much to Chris and Pamela for this great presentation. What a great slide to end on about the co-benefits of this work too. ILFI has been very involved in the ECHO project as well with Pamela and others, and it's been really great to see the alignment around reporting and accounting and where we all need to head with this. So we will jump into a Q&A session now. We have a little over 10 minutes, and there have already been questions in the chat, so I'll start with those. If anyone else is pondering questions that you'd like to add to the chat, please add them there. So back earlier from Chris's portion of the presentation, Erin had a question around the embodied carbon numbers, asking, can you explain more on how embodied energy is so high compared to the energy used during the lifetime? And it says of the building, so maybe that's clarification on that. Is that a question?
So specifically to that, that stat is regarding landscape spaces. So parks, plazas, streetscapes. The vast majority of the life cycle carbon of a landscape is for urban spaces that have lighting and fountains and things like that. It's more like 75%. For more rural spaces or more naturalistic spaces, it can be lower. It can be up to 90% of the net life cycle emissions will be in the construction of that project. For architecture, it's closer to 50-50.
Okay. I think the clarification on, landscape versus building is helpful there. Thank you. Next questions for Pamela. Carolina asked earlier, this is sort of as you're, before going deep into the Pathfinder tool, but talking about sort of the scale switching across the landscape, landscape solutions. She asked what scale of architecture would lend itself to use landscape elements to offset building carbon life cycle costs. Do you have examples of designs that took into account building plus landscape? Which I'm sure is a question that might come up frequently, especially from architecture crowds, but.
And I might let Chris take this one because I know he's been looking at both the landscape and the buildings. I mean, I think we know that the building emissions are so significant that it takes a lot of space to be able to come close. But Chris, do you want to give more specific examples?
It takes a lot of space, yeah. So one of the things that, this is kind of one of the questions why we wanted to make carbon conscious both architecture and landscape together, is that intuitively I've attended developer presentations where they show this wonderful, recreation complex building, and then they talk about all the carbon sequestered by the 5 trees they have in their plaza, and it's not gonna be anywhere even close. I'm finding that in general per GFA, if you have a low carbon design building, so I'm talking about mass timber style structures that are under 8 stories tall, we're looking at about 10 times the GFA of the building in restored natural systems to generally offset them. When we're looking at high carbon buildings, like skyscrapers that are primarily steel and concrete, we're looking at closer to 100 times the equivalent GFA, just to put it in rough order of magnitude. Now that said, we've also done some studies on some very small structures that are very sensitively and extremely low carbon design structures that get as close to carbon neutral as architecture possibly can, where we're looking at, a equivalent of like less than 250 kilograms of carbon dioxide equivalent per square meter of architecture. And in that case, we're getting, much lower ratios, 2 to 5 square meters of restored ecosystems compared to a square meter of the facility, of the architectural facility. So there's such a huge range in how we build that we have to think about decarbonizing our buildings, decarbonizing our landscapes, and thinking about how we're going to offset those in the living environment. this is also a plug that I do believe that there are places where we want to invest carbon. Like we want to have infill development in our cities because that'll be ultimately the lowest operational carbon for our communities to move forward. The lowest operational carbon footprint per citizen in the United States is for New Yorkers who live in the boroughs. It's not for people living in large rural landscapes. So I think there's a role for us to start thinking about, for cities to start thinking about their carbon shed, the carbon that's in the rural areas that can support the urban areas' carbon investments. And that's ultimately when we start thinking at that scale, where we can maybe connect investments in buildings in urban areas with offsets and investments in protection and restoration in large landscapes in rural areas, where we can start thinking about whole city carbon neutral design.
Yeah, that's interesting. Great, very in-depth answer on that, and definitely goes to tie into the presentation overall of where we really put focus matters, and doing less harm at the beginning is one of the solutions to getting there. Really focusing on where we do spend that carbon. Two questions that came up next in the chat. I'm going to tie two together because they're quite related. They're sort of Pathfinder calculation questions. One from Mamata and one from Kelly. And they are around, for Pathfinder, does the calculation change per plant types, whether it's ornamental versus natives, or, you know, native plants, things that may have a difference in need for water and other maintenance? And then another question in that is, does the tool take into account water savings and biodiversity benefits from using native plants? I want to tie those into one question there.
Good question. It's almost like I paid you to ask that. but seriously, we are working on that. It's our plan for the upcoming year, is to start adding in those additional factors as well. So yeah, super important. Again, I think just linking the climate and biodiversity crisis too, and we want to make sure that we're not exacerbating one or the other, right? So, you know, being smart about making sure we're not planting a ton of bamboo just because it sequesters a lot of carbon and then it destroys an existing ecosystem and sucks up all the water, right? So I think, you know, at the end of the day, obviously we have to just make like good, thoughtful design choices, but I do think pulling in those metrics and linking them up together is going to be really effective. So stay tuned. Hopefully fall next year, you'll be seeing a tool that incorporates those things as well.
Nice, great. The next two are also tied to Pathfinder questions, but around sequestration. So I wanted to link those together too. The first is from Aaron. For the sequestration for planting, is it that sequestered in biomass as plants mature on site, or does it assume a disposal method of green waste that sequesters carbon in some way? And then I think tied to this, Nick asks, how much sequestered carbon is re-released when landscaping is disturbed? So there are some questions around how we're calculating that during the sort of the use phase and maturing of the plants and disposal on site as well.
Yeah, I can start with that, but I think Chris also has the wealth of knowledge that he can share on there. So just specifically, yes, the sequestration for planting, that is what we're talking about. What is stored is sequestered through photosynthesis, whether it's stored in the plant biomass itself or it's migrates into the soil below. So that primarily that data, and Chris, you can also again jump in on that, but that's what we're, you know, our assumptions are basically. And there obviously is carbon anytime that basically biomass decomposes, that carbon, you know, a good portion of that is carbon is released back up into the atmosphere, right? So it can be if you're cutting, you know, limb of a tree, right? And that decomposes, you know, it lays on the ground and then it decomposes, it gets released back up into the atmosphere. Some of it may get absorbed back into the soil. But even thinking about mowing blades of grass, they take in carbon when those blades are cut, they fall back down to the ground, they decompose, they release a good portion of that carbon back up into the atmosphere. And so it is factored into that equation.
Yeah, I can talk about this for another whole education session, but I'll try to keep my thoughts brief. Usually when we report on carbon sequestration, both Pathfinder and Carbon Conscience, we're talking about carbon that's stored and living in dead biomass for a given time period. And by dead biomass, I mean the decomposed materials that Pamela is mentioning, a percentage of which ends up getting locked in soils. Soils are our kind of secret weapon for storing carbon in living ecosystems. Most ecosystems do hit a carbon carrying capacity, and not all ecosystems are equal. Some ecosystems can store much more carbon than you would expect. For example, for some of those bay projects that Pamela was showing, salt marshes are kind of like a carbon superhero because they lock up all of their dead biomass and anaerobic benthic sediments, more or less, or about 90% of it over a time period. That's wonderful. When we're looking at, I'm working a lot in the Mediterranean right now, and there it doesn't store a lot of carbon in dead biomass or in the soil. So you really are limited in how much carbon that ecosystem could potentially lock up long term. So it really is the time period of the study. That's why climate positive design represents years to positive. So that's accounting for the carbon that's pulled down over that study period. In carbon conscience, we define a single point in time to correspond to whole building LCAs where we pulled a lot of our information from architecture. So we just have a single static point in time at 60 years. Including decomposition assumptions year to year for herbaceous material, as well as different rates of decomposition for woody material. I can talk more about that if there's more questions about it, but that might be enough for now.
One quick follow-up question that's somewhat related, not in the big picture, but more detailed, is if there are separate equations for Mo-free or low-Mo sod solutions.
There are in the Pathfinder, yeah.
Okay, great.
And they are surprising. So go in there and compare them because it's super interesting. High maintenance lawn is typically a net emitter. So
yeah, definitely.
Yeah. Wow. And then there are two other questions in the chat that I think will come in right on the wire for. One is from Robert about attending the ASLA conference this week and who people can connect with or specific places to acknowledge at this conference. Chris, are you there?
Yeah, I'm here. I have 3 sessions over the next few days. So you're welcome to come see any of those. One's specifically on materials, one's on getting to 50% and what does that look like, and another is an update for what the Climate Action Committee has been up to. We actually have 3 sessions on that, and one is just on specifically the kind of carbon drawdown and the field guide that's in the expo floor. So there's also, I recommend, there's a climate action track as an educational track at ASLA this year, and I think there's 11 education sessions, as well as a couple of field visits, and then all of the expo and PPN sessions. So there's actually like way more opportunities than I have time to attend, and a lot of them are happening at the same time. But it's becoming an important part of our annual conference, which is great because I think Pamela can also agree. 15 years ago, we weren't even really allowed to talk about climate action or climate change at ASLA. And it's a radical sea change for our professional society. It's great.
Yeah, that's great to hear. Thanks for all the good resources there. There was a final question on specs for alternative concrete mixes that can be shared for conversations with local suppliers. And I put in the chat, I know SE 2050 has a resource on that, but if there's any others that you may have that are landscape specific, we can share those in the chat as well. But I do see we're getting close on time. I think we got every question. If anyone wants to hang around and follow up, I can stay on for a few minutes, but thank you so much.
Specs. I was just going to say, I highly recommend the Rocky Mountain Institute summary. That's a wonderful place to look. I'm also working on a spec guide for landscape architects specifically that hopefully will be published later this year. You can see the work in progress posted on the Carbon Conscience website, including a preliminary concrete section. But it's a work in progress, so I welcome anyone's critique.
Great, thank you for those resources. And thank you to Pamela and Christopher. This was a great presentation, great engagement, really good questions. And we look forward to continue to working together. Yeah.
All right, be well, everyone.
Thanks for having us. Bye.
Bye, everyone. Thanks for joining.